my name is Rachel Proke. This is Unit 11, Atomic Structure and Bonding. The presentation will explain the electron structure of ions and the difference between an atom. Ionic bonds will be explained and the formation related to their electron structure. Covalent bonds will be discussed, including the various types. Dot and grass diagrams are presented, identifying simply covalently bonded molecules. An ion is an atom or molecule that loses or gains electrons. This then causes an unequal number of protons in the nucleus, also producing an unequal number of electrons in the orbitals. The formation of ions is dependent on the loss or gaining of an electron or valence electron to become stable. This requires energy. Example, sodium. Ions are considered stable when it has a noble gas configuration. Ions occur due to an imbalance of protons and electrons. Protons define an element, example carbon. Atomic number 6 has 6 protons. If there is 5 electrons, 1 less electron, a cation, which is a positive charge, would occur. Another example is boron. Atomic number 5 has 5 protons. If there is an additional electron, 6, it produces a negative charge, an anion. In terms of electron structure between atoms and ions, an atom has a neutral charge which contains the same amount of protons and electrons, and an ion has an electrical charge which occurs by the removal, which is a positive ion, or addition of electron, a negative ion. The electrical charge is what makes an atom and ion different. The loss or addition of electron affects the physical and chemical properties of an atom. A positively charged ion occurs due to the atom losing an electron. A negatively charged ion occurs when the atom gains an electron. Ionic bonding occurs when valence electrons are lost from one atom and gained from another, becoming more stable with an electron configuration of a noble gas. An ionic bond is formed when the atom's electronegativity have a normalized surpassing 1.7. When dissolved, a compound is formed that conducts electricity. Various conditions are required for ionic bonding. Opposite charges of elements are required for ionic bonds to form, with one of the atoms needing a low electron affinity, allowing positively charged ions to form from lost electrons. The other atom needs a high electron affinity, allowing negatively charged ions to form from gained electrons. Ionic bonds have various properties such as ionic compounds, which are stable in a solid state due to a high lattice energy. They are brittle due to ions being in a crystal lattice. Ionic bonds cannot conduct electricity in a solid state. Another example of an ionic bond is sodium fluoride. Sodium loses a single valence electron to fluoride. The ions are attracted to each other due to the electrostatic forces as they are opposite charged. Due to the atoms being shared through covalent bonding, the outer shares are filled, appeasing the octet rule, which is a combination of atoms which provides 8 electrons in their valence shell, determining an electron configuration which is analogous to a noble gas, applying to S&P electrons. Covalent bonding is a significant approach in chemistry. Shared electron pairs correlating to chemical bonds was founded by Lewis in 1916. Over time, theories were expanded by Lemur 1920. Research and advanced the octet rule, introduced the 1832 electron rule, but also proposed the term covalent bond, which is the electrostatic attraction between the shared electron pair and the opposite charged nuclei. Covalent bonding occurs if atoms have comparable electronegativities and they have the same affinity for electrons, as the electrons will not get donated. To become stable, the atoms share electrons, fulfilling the octet configuration. Sigma orbitals are formed when the atomic orbitals overlap head-on, occurs between s orbitals. This provides a strong bond, cylindrically symmetrical, encompassing the bond axis. These provide support for single bonds. When atomic orbitals overlap sideways, pi molecule orbitals are formed. An unsteady and more reactive bond that is below and above the internuclear axis. Double and triple bonds are stable through the orbitals not being cylindrically symmetrical. A single covalent bond is when one pair or 2 electrons are shared between atoms. The notation for a single covalent bond is a single dash between an atom. A double covalent bond is when two pairs of electrons or four elements are shared between atoms. Notation is a double dash. A double covalent bond consists of a pi and a sigma bond. A triple covalent bond is when three pairs of electrons or six electrons are shared between atoms. Notation is a triple dash. A triple covalent bond consists of two pi and one sigma bond. Other covalent bonds exist, such as polar covalent bonds. Atoms that share electrons have a significant difference in their electronegativities, example H2O. Non-polar covalent bond, example CH4. There is zero electronegativity difference between atoms. Coordinate covalent bond. One of the atoms provides a shared pair of electrons being held together due to the electron pair being attracted by both nuclei, example BF3. During the process of covalent bonding, an energy loss occurs, which is exothermic process, due to the atoms forming a bond to become stable. The following elements have been identified as being simply covalently bonded molecules. Methane, CH4, has four non-polar covalent bonds. Non-covalent bonds form between two different atoms. To fill the outer shell, a carbon atom must gain 4 electrons, making one covalent bond. A single carbon atom forms 4 covalent bonds with 4 hydrogen atoms, sharing a pair of electrons between each carbon and hydrogen atom. Electrons are equally shared between the carbon and hydrogen. Ammonia. An atom of nitrogen and 3 atoms of hydrogen, non-bonding pair of electrons. For the last shells to be filled, electrons are shared in pairs. Nitrogen and hydrogen atom has an electron configuration of noble gas. Hydrogen atom forms one covalent bond due to only needing one electron to fill the outer electron shell. Water, H2O. For the outer electron shell to be full, oxygen needs to gain 2 electrons, whereas the hydrogen atom needs to gain 1 electron. In the last shell, the oxygen atom has 4 electrons, forming 2 lone pairs, which are not used in bonding. Atoms in the water molecule have a noble gas outer p6 electron arrangement. Hydrogen chloride. One atom of hydrogen combines with one atom of chlorine to have full outer shells. Both atoms share an electron. Hydrogen and chlorine combine to form hydrogen chloride. Hydrogen is electronically like helium and chlorine like argon. When atoms share their outer electrons, hydrogen and chlorine have full outer shells when covalent bonds are formed. The atomic structure, preferably the outermost electrons, play a crucial role in how an atom behaves. Due to the position of an element in the periodic table, elements are grouped accordingly to their properties. Example, an element in group 1 contains 1 electron in its outer shell and has a weak attraction to the nucleus. A low ionization requires low energy to remove an electron from an atom. Ions also affect atomic structure, with the atom having a positive or negative charge. The difference between an ionic bond and a covalent bond can be determined that an ionic bond and a covalent bond are both types of atomic bonds, which vary in terms of their structure and properties. The electronegativity difference of an atom is dependent if an atom loses its electron to another atom, resulting in a cation, which is a positively charged ion, and an anion, which is a negatively charged ion. This is known as an ionic bond. The electronegativity, which is the pair of attraction of an atom, determines if a covalent bond is formed. Thank you.